Good evening, guys from Sweden. Like Prajit mentioned, I am Sachin. I am currently working and living here in Athlone, Ireland. I hope all of you are safe and secure in this difficult time of COVID-19. And thank you for joining this this evening. So I'm going to share my screen and we will start this session on cloud computing in general and Google Cloud Platform in particular as a tool as we go along. This is a hands-on session, so if you have a evaluation GCP account, you can work alongside me. So I will not talk a lot. I will not explain a lot of things in cloud computing because at this stage almost all of us have a fairly good idea about what cloud computing is. But just in case if there is any beginner in this group, I quickly will explain some of the concept and then we will straight away go into examples. I hope that's fine with you. Okay, I'm sharing my screen now. I hope my screen is visible to all of you. Can some of you just confirm whether you can see my?
I can see it.
Brilliant. Okay, so let's start. Like I mentioned, my name is Sachin Sadasivan. I work as a software developer for last 12 to 14 years. Currently, I'm working with a company here in Ireland called Ericsson. I work primarily in microservices with Java and cloud native application development. We also use OpenStack as our primary cloud, but I have a lot of interest in other cloud platforms like Google Cloud, Amazon Web Services, and Microsoft Azure. So, like I already mentioned, this is just getting started in cloud computing, so we'll not be going into the deeper concepts or demos. This is just a beginner's course with the hands-on exercise on Google Cloud Platform. So the agenda today is we will briefly go through about cloud computing. We will talk about Google Cloud Platform. We will quickly have an overview about GCP resources, how to access these resources, what is a project, what are the various zones and resources. Then we'll create a Google Cloud account if you are not familiar with that. Then we'll see the fundamental GCP services, which is compute, storage, and networking. We'll also talk about the pricing small bit. Then we'll see what are the various ways to interact with the Google Cloud Platform. And we will also do hands-on exercise while doing these various agenda items. So let's start with cloud computing. Like I mentioned, this is an overview with the basic principles of cloud computing. So when we are talking about cloud computing, I'm sure you all know that there are three different types of cloud. One is public cloud, private cloud, and hybrid, which is a combination of public and private. So GCP is a It's a public cloud offering. This is the definition I have copied from Wikipedia. This is a, comprehensive explanation. But if you split this into smaller pieces, we will understand that cloud computing essentially is a way in which you are executing, you are computing, and other resources in a server which is available on demand for you through various interfaces. In other words, if you look at your computer, your laptop or your personal computer, you can see there's a hardware associated with those components which you can touch and feel from outside, especially keyboard, mouse, camera, your monitor, and other interfaces. That's probably the external part of that. And internally, we have other hardwares like various chips, memory devices, the networking components, etc. Then from the software side, you will have an operating system running on your computer. That operating system probably will interact with various other resources within that, and also with the external world through various APIs and other softwares. So if you split all these components we already spoke about and place in different areas or different places in a network, and then we connect these resources, both hardware and software resources, by means of high-speed network, that will enable us to interact with these resources in real time without really having all these components within a small box or within a server in your premise or in your house. So all you need is an interface just to access these resources. That's one simple definition of a cloud service. So these resources are still exist. These hardware and software still exist. This networking still exists, but this is maintained and developed by a third party. The advantage of doing so will be explained in the next few slides. So the fundamental benefits of using cloud computing, as you can see, in my opinion, is these four. First and foremost is the agility, elasticity, deployment, and cost savings. When you're talking about agility, it's much more easy to access to a broad range of technologies. You don't need to really purchase and keep that within your company or your home to access any new technology which you might find interesting for your application development or for your usage. And in the past, if you are maintaining this infrastructure in your own premises, probably you need to deploy yourself, and you know the complexity involved in deploying an enterprise level application with various levels of availability and fault tolerance, etc. And then in terms of innovation, it will allow the organizations and individual to concentrate primarily on the innovation and the ideas rather than thinking about the infrastructure around that. So cloud computing is very agile in terms of using these ideas and translating that into business use cases and opportunities. So scaling up and down is quite easy in a cloud environment. That leads us to the elasticity. You don't need to provision resources in advance. Like in the past, if you want to start an enterprise or a business, you probably one of the first thing you probably would do is to purchase the hardware and the software, which potentially is required for your application to run. That's a guess. So you need a lot of upfront cost associated with that approach. So you need to invest a lot upfront to begin with. But in the case of cloud computing, if you're using that, it's always pay as you go. As long as you have your, as soon as you have your idea, you can start a prototype with very small resources on a cloud computing. And if that materialize, you can further expand your resources associated with that. In that way, you don't have a huge upfront investment. Rather, the investment is all in your innovation and your idea. And with cloud computing, you can deploy across multiple regions across the globe. And you can also have your applications and resources running close proximity with the users, regardless of their geographical locations. Then cost saving, like I mentioned, the upfront cost is very less, and you only need to pay for the resources you use at any point in time. And tomorrow, if you decided that you don't want to continue with this resources and infrastructure, it's very easy for you to change that and move forward. While talking about the elasticity, one of the myths about cloud computing is that many a time people think that these resources in the cloud is infinite, which means that you will have these resources available for you to any extent you would like. But the reality is that the cloud has finite resources because those are real physical servers, softwares, networking, etc. So it's always finite, it's not infinite, but it's all up to the users to use these resources wisely. And cloud providers themselves are very defensive about this. In most of the commercial cloud providers, the account will always have a quota associated with that. So it's not so easy for you to go beyond your quota of resources. This is to serve two purposes. One is for the cloud providers themselves not to go beyond the available resources, and the second is to avoid the users using their resources without their own knowledge. For instance, if there is a spike or if there is an issue happening in your application, and if it uses infinite amount of let's say memory or CPU or other resources, then you will be billed for such a high usage. Probably that could be an error or a bug in your application, but that will cost you a lot. Since you have quotas that always give you a warning, and you are always warned about the unusual usage of the application. So that will prevent ourselves as a user of the cloud resources. We already talked about the computer, and we divided that into various components: processing units, storage, networking. Now all these components are divided in various places on cloud computing. So we still have these things, just like we have laptops and PCs, but these resources are located in different places in different quantity, and all of them are connected by high-speed networking. Okay, now, and in cloud computing, we have various compute choices. In fact, we have a spectrum of compute choices available. From our left-hand side, we start with the bare metal, which is the traditional software running on-premise. And if you go to the right, you have more advanced options or advanced infrastructure running on a network or a cloud. So starting with VM instances, that's stand between the bare metal and the other cloud resources, basically provisioning your virtual machine and virtual instances. It's up to you to manage and maintain. Then we have container clusters, mostly with the containers and container orchestration technologies like Kubernetes, for instance. That stands in approximately in the middle of the spectrum. So you have most of the management of creating the VM instances and maintenance is taken care by the cloud themselves with the containers and clusters. So it's much more advanced than the VM instances. Then we have the hosted applications where you don't need to even worry about VM instances or containers. You can just deploy your application, and scaling, high availability, replication, etc. are automatically taken care for you. And then towards the right, you have the serverless, where you can just write your code and execute that. You don't need to worry even about hosting that application. These are the basic computing choices we have in cloud computing. So when you're talking about these computing choices, if you look at the spectrum again, if you go to the left, towards the bare metal, you can see that you have more control, you have low-level accesses, but you have the overhead of maintaining that within yourself, both the resources, the infrastructure, and networking. On the other hand, if you go towards the right, you can see that the operation and maintenance cost is very less. The overhead is already taken care by the cloud providers, and it's completely abstracted from you. So it's a decision taken during the development of your application. What is the right approach suits for you and your application within these compute choices. Now, let's talk about Google Cloud Platform, mostly known as GCP. So Google Cloud Platform, just like AWS or Azure, offers infrastructure as a services, platform as a service, and serverless. So infrastructure as a service is primarily provisioning virtual machines and so on. Platform as a service, just like we saw the application deployment like App Engine. And towards the right of the spectrum, we have serverless. In case of GCP, it's known as Google Cloud Function. So what is making this GCP unique among some of the other competitors? Almost all these cloud providers offers same level of application and functionality. But the technology underlying Google's network is a key differentiator, making it a very compelling cloud service provider. Let's have a quick look at some of Google Cloud Platform standard features and how it stands out from the competitors. First and foremost is the networking. Google has invested heavily in recent years to make their network very competitive compared with other commercial cloud providers. They have their own high-speed fiber network across the globe, throughout the continents and underneath the sea, which connects between various data centers. Most of the other cloud providers, on the other hand, uses a combination of these. They mostly rely on the telecommunication network provided by other third-party vendors. That means Google's network is completely tuned and dedicated to support these kind of communication in cloud. The second thing is the pricing. We will see how the pricing differs in case of Google. And technology and innovation is something which always make Google a very, very attractive choice when it comes to using technology. For instance, Google themselves developed some of the technology used within the cloud computing, like Kubernetes, Google MapReduce for streaming, and TensorFlow for machine learning and other AI-related applications. So in the case of Google, the spectrum of compute choices we already discussed will be like this. The bare metal, or from the bare metal side, if you look at this, the VM resource provisioning is taken care by Google Cloud Compute Engine, and the container orchestration is Google Kubernetes Engine, and the application deployment is Google App Engine, and serverless is Google Cloud Function. And here is a quick overview of GCP Building Blocks. In the lower blocks, we already discussed the processing, storage, and networking of a typical computer. And that's the building block, the fundamental building block of that. On top of that, we have big data, machine learning stack. These stacks are abstracted from the end user using the management layer, and on top of the management or the API layer, there are various development tools and interfaces using which we can interact with these underlying resources. We are going to see a few of those now. So I was talking about the Google infrastructure, and we can quickly have a look into the Google infrastructure from this link now. I will open this link and show you that very quickly. This is a live view of Google Cloud infrastructure. It spans across 22 regions, 67 zones, and 140 points. So if we quickly look into this, you can see Google's global network of the high-speed fiber network I was talking previously. These are some of the data centers, and it's all well connected with the fiber network. Like we already mentioned, this is completely developed and deployed by Google for their infrastructure. So it's not shared between any other operators or third-party services. That makes it very competitive. So I will let you go through when you get a chance about cloud.withgoogle.com infrastructure. Okay. Now in the platform itself, like we already discussed, there are three components of a computer: compute, storage, and networking. And these are some of the examples of various applications in these three different areas provided by Google Cloud Platform: App Engine, Kubernetes Engine, Cloud Data Store for storage, and for networking, you can have virtual private cloud, external IP cloud, cloud firewall, etc., etc. So now in this talk, we primarily focus on Google Compute Engine. It's not possible to cover all the areas of GCP in a very brief discussion like this. So we just concentrate on Google Compute Engine, which enable us to spin up and use virtual machines of various types. This is information as a service offering from GCP running on Google's data centers. You can have Linux or Windows-based images, or you can also have specialized images. You can also have your own custom images running on these services. We'll see the pricing as well as we go along. While developing this infrastructure as a service on GCP, you have various choices like location, networking, configuration, storage, administration, etc. We will see that shortly as well. Just before going to the real demo for setting up a GCP account, I also would like to take you through the Google pricing calculator to get a feel of how pricing is taken care by GCP. So identifying your upfront cost in GCP is very easy. Like I mentioned, for instance, if let's say you're hosting a web application on, let's say, Kubernetes engine in this case, and you are expecting the number of nodes to be, let's say, for simplicity, and you can see an estimate of that as you go along. You can use additional information if you have, but let's take it simple for now. And you are going to use the standard instance in this example. And based on your usage type, there will be discounts. If you're using for 1 year or more, you will get a committed usage discount. If you use 3 years, you will get even more discount for that. And then you can also use other informations like persistent storage you are expecting for your application. In this case, I would say 10 gig of persistent storage for my application. Then if I add that to estimate, I will get an estimate for the duration I am going to use this. In this case, it's 3 years. So it's $62.42 per month. And if you continue, let's say you need additional storage, let's say cloud storage. And if you want, let's say 20 GB data and data retrieval, you can mention and if I add that to estimate, you can see the total of $82.62 per month. So it's very easy for you to calculate the cost, which might be applicable for your application. So if you understand the structure and the architecture of your application, you can come here and select various GCP resources associated with that while deploying on Google Cloud, and you will get an estimate of that based on your usage. Now let's go to a more interesting stuff in this, interacting with GCP resources. What are the various ways to interact with the Google Cloud Platform services? There are primarily 3 different ways to interact with GCP. The first and foremost is Web Console. It's an interactive user interface in which you have various options to interact with the GCP services. Then you have the Cloud Shell, which is a command line access to your resources from the browser. So you can access that from the user interface itself. The third option is Google Cloud SDK. You can download Google Cloud SDK from the link shown here and install on your computer based on your operating system. Since I'm using Windows, I use Windows installation for this Google Cloud SDK. But if you have any other operating system, you can find the SDK link for your operating system as well. So we are going to interact in this demo with all these 3 different options. I will show that one by one. Okay. With that, I'm going to cloud.google.com. This is the home page where you can create a Google Cloud account. for anybody who create a Google Cloud account with a existing Gmail account, you get an opportunity to use GCP resources for an year free of cost up to $300 US. So for most of the learning and exercise, it's good enough. So I created such an account, and I'm going to demonstrate all these demos within that account. If you already have an account, that's great. But if you don't, I strongly encourage you to try this to create the GCP account, and it's free of cost up to $300 for a year. So once you created that account with the formality of giving your email address and a credit card, you will be getting the information to log into the cloud console, which would look like this. This is a very easy, interactive user interface, just like the normal Google applications. On your left-hand side, there's a burger icon, and if you click on that, you will see home page and various product information. Since I've been using Compute Engine for quite a number of time, I have added that as a favorite item here, which is why it's coming under home. But you can do that with any other application. Within here, you can see all the products available in GCP, all the way from marketplace to billing, services, Compute Engine resources, Kubernetes engine, storage, Bigtable, file store, SQL, Cloud Spanner, networking resources like virtual private network, hybrid connectivity, security. And then in terms of monitoring, you can have logging, tracing, profiling, etc. You also have additional tools within here. Then those of you who are interested in big data, you have a lot of applications to support big data, BigQuery, publish, subscribe framework for notification and message handling, data fusion, life science. And for those who are interested in artificial intelligence, you have all the AI related APIs like natural language processing APIs, TensorFlow, vision control, video intelligence, so on and so forth. So the list goes on and on. I would leave this up to you to go through this whenever you get a chance. So I'll quickly explain this user interface very briefly, and then we will start with our exercises. So in GCP, on top, you can select the project you are working on. So this is one of the topic in my slide already, but I'm going to explain what is a project. In Google Cloud Platform, everything is associated with an organization. Like, you know, if you have your own organization, that's the root of your GCP account. And within the organization, you can have various projects, and various projects can have various users, applications, and other resources. So in my case, this is just a demo. So I do not really have an organization, but I created a blank organization or no organization, and underneath I created a couple of projects. As you can see here on top, all your projects will be displayed in this. So in my case, I have 3 projects, and the one I'm going to use for today's demo is known as Cloudy Basket. That's a hypothetical online superstore where you can purchase applications and other supermarket items in that. So that's the product I'm using as a root for today's demo. Then on the top, you have an active Cloud Shell, and obviously You have the help and then notification. We are going to see some of these very shortly. On your left-hand side, you have your project info. In my case, it's a project name. The name and ID should be unique, and Google will generate you a project number. You can delete and remove a project anytime, but once you remove that, you will not get the deleted resources back again. And here in the right-hand side is another important information in terms of billing. If I click here, this gives me an information about the billing associated with this project in particular, and about the usage of my organization. Okay, so let's go back again. Back in home. We also have other information and a lot of shortcuts on your homepage. You can obviously activate, hide, or show various applications as you wish. Now, let's go back to our presentation and see what's next. Okay. So in this lab, we are going to create a quick virtual machine. We are going to decide what's the image of that image to be used for that virtual machine. What is the memory required? What is going to be the data storage if you're planning to do so, etc. in that. So let me create a Google Compute Engine VM instance. If I already created any VM instance, that should have been displayed here. Since there is none, I'm going to create a VM instance. Now, before creating the VM instance, let me talk about the images themselves. So in GCP, there are two types of base images you can use when creating virtual machines. One is public images, and the second type is your custom images. Within the public image, then we have two types of images, free and premium. Example of free images are CentOS or Debian. And apologies for the mistake in the slide. Example of a premium is Red Hat and Windows Enterprise. So for this demo, we will go through the free way. We will either use CentOS or Debian Linux images. Now, if you go back in this create an instance page, you have the option to give the name of your instance. So I'm going to give a name as, let's say, Cloudy Basket website. I can optionally add a label to identify these images using key value pairs. If you wish so, you can add a label, and that will accept a key as a string as a key and another string as your value. It's an optional thing. So while I create the virtual machine, I also would like to see what's the cost involved with this virtual machine. If you look at the right-hand side, you can see the cost associated with as we select various options. The next important thing is to decide the region where your VM should run. The region is very important because the pricing is associated with the region. Now, by default, it's selected US Central 1 Iowa, and the zone is US Central 1A. Each region will have multiple zones within that. On the other hand, if I select a different region, for instance, Europe North 1, As you can see, the price varies. Now it's 27.1. If I select something in Asia Pacific, for instance, the price again varies. So it's an important parameter to be selected carefully based on the budget of your application development and deployment. Okay, I'll go with the default, which has $24 per month for basic items. And I will also leave the zone as default. Now, the next important decision is to decide the machine configuration. You can either use a general purpose machine configuration, which is cost optimized, or go for more memory optimized for higher memory configuration. But of course, your price will vary when you do that. Or you can go for compute optimized. In that case, you yourself can decide if you need a high-end CPU services or vCPU record for this. Again, this will have an impact on the pricing. Look at this. I have chosen a very high 6 vCPU, 240 GB memory, and it's quite expensive per month. So you need to decide what best suits for your application, whether it's a memory optimized or a compute optimized, or can it work within the general purpose cheap machine configuration. So in this case, I go with the default, which is N1 series. You can change that if you wish. And then the machine type, I go for standard machine type. Again, it's up to you to choose different machine type. You also have additional option to select CPU, platform, and GPU. Your cost is going to change based on that decision as well. I will leave that as optional, as default, for instance. Then the boot disk, by default, it's Debian Linux 9, which is a free image like we have seen, but you can use more proprietary images like Windows or Red Hat as well. We will see that probably in our next demo. So right now I'm leaving it as it is, but if you wish, you can change this to any other operating system type and the corresponding version. And the size of your boot disk also depends on your requirement. Remember that will depend your pricing as well. So all the resources you create will be associated with a service account, which is associated with our own GCP account. So the service account is default. And I will let all other cloud APIs to get access to these virtual machines we are going to create. And in terms of firewall roles, I will allow HTTP as well as HTTPS traffic. And then I am going to create this instance. So now the virtual machine is being created. As you can see, notification shows create VM instance with this name and is booting up now. Now it's completed and the virtual machine is ready and available for our usage. Now I can SSH into this using various options. Either I can use a browser window from here, or I can use another SSH client or use various other options mentioned here. So we will see both. So if I open a browser window here, as you can see, now it is being connected to the virtual machine we have just created, and we are doing a secure shell session to this virtual machine. When you create first time, it might take few seconds to get the connectivity established between the VM and your local browser. So as you can see in the monitor now, I am connected to the Cloudy Basket website virtual machine I have just created. So I am in my home directory of my virtual machine. Okay, so if I close this, so this is one way of creating a virtual machine using the web cloud user interface. You can also use command line to create the virtual machine instances. So if you go back, now we were using GCP Web Console, and we created a virtual machine from the Web Console. You can also create virtual machine from Cloud Shell. So I'm going to show how to access a Cloud Shell. So if I go back, this icon will activate a Cloud Shell for you within your browser. The Cloud Shell will have all the Google Cloud Platform infrastructure pre-installed in this shell, and it's ready to be used. Let me try to connect from here to there. Or rather, I will go here and open the Cloud Shell. So I have the option to choose the project. I think I have already chosen that. I should be able to access it. Probably I'm missing something here. Anyway, so that's another option to create an instance using the command line. So instead of using the web console, you can use the Cloud Shell to create virtual machines. But the most widely used interface is neither of these. That is Google Cloud SDK, which will allow you to manage your resources, create, update, delete, etc. from your local computer. Most of the time, the developers and organizations will have automatic script, which will enable us to maintain these resources in cloud. And I'm going to show that in a second. one of the easiest way to find that is create an instance. Let's say services. And we'll leave everything as default, like we mentioned. And instead of creating, we can use the option command line. So you will get the Google Cloud compute command to create these resources. So if you close this, and if I cancel this, I still have only one virtual machine. Now I will open the Cloud Shell. So like I mentioned, I already installed this Cloud SDK. I downloaded from the GCP download page for Windows, and I set up that in my local computer. So when I use this, I need to give the credentials and initialize it using my GCP account. If I initialize this, it's going to ask me what's the configuration to be used. I use the existing configuration, and it's making a connection to GCP using my account, which is listed in number 1. And it also asks what's the project I would like to access. As you have seen, I have 3 projects, and I'm going to use the first Cloudy Basket project. Would not like to wish to set the zone. So now I am connected to Cloudy Basket project. The next I'm going to execute the command we have seen from the UI. So if you closely look into this command start with the G Cloud. It's a beta project, very latest, and it creates a compute instance, and the name of the project is this. So it's going to create the instance underneath the Cloudy Basket, and instance create command takes the name of the virtual machine, its zone, and other default information we have selected from the user interface. So basically, this is the command line way to create a virtual machine. Like I mentioned, in real-time environments, one of the most commonly used way is to create and manage resources using command line. So if I click enter now, gives a warning about the disk size, but that's okay for this demo. We are not worried about the performance. So if you look at the output, you can see the service has been created under the zone US Central with standard machine type, and these are the IP addresses, and its status currently is running. We should be able to see this if you go back to our home page now. So if I go back to here, I can see the Cloudy Basket service I just created through the command line interface. So we just created a virtual machine from command line. Command line can be used for pretty much all the operations we do in this web client as well. So you can create, delete, remove, update, whatever you can do here, everything can be done from command line interface as well. Now, okay, so that was a Windows instance, Linux instance. Now let's quickly create a Windows instance and see how to access a Windows instance, just like we SSH now. For that, I go back again. create an instance. I will say Cloudy Basket Service Windows. I will leave everything as default, except the fact that I change the boot image from Debian to Windows Server. If you look at closely, the size for Debian images is 10 GB. And if I select Windows Server, you can see there's something funny going on here. I think my internet connection is slow. It's not getting updated. Let me cancel and try again. It's 10 GB. And if I select Windows Server, sorry about that. Because of some reason, it's not. Okay, yeah. It's not automatically getting updated. It should have been. Okay, now it's working. So when you select Windows Server, as you can see, the boot disk type increases automatically, and that will have impact on your pricing. And second thing is that since Windows is a proprietary image, your cost will also be high. So if I select this, and if I see the details, so the monthly estimate is much higher than the normal Linux images. And I select everything default and create the Windows virtual machine. In the case of Windows virtual machines, though, there is a little bit of time it's going to take to get the Windows VM up and running, primarily because of the system util creation in Windows operating system takes more time than Linux. So even though you see the Windows VM up and running here in background, that might not be the case yet. So one option is to check with this command using the Windows serial output. So if I go here, and activate the Cloud Shell, and just fire this command with the name of our service. Take a while. Takes few minutes for Windows to basically come up with. So while we are waiting for that, is there any questions so far? I'll be happy to answer or discuss if you have any comments. All of you are quiet. I hope you can still hear me okay. Hello, can you still hear me okay? Okay, I just noticed the chat there. Apologies, I'm not so familiar with the Zoom, so I'm just trying to figure out how to reply for the chat. Okay, I can use the URL. Okay. Yeah, in the meanwhile, we got a success message for our Windows virtual machine, so everything should be fine. And I will paste that URL for your reference here. This is the command to check whether a Windows image is up and running. Obviously, you need to use your image name here. Windows VM name, I would say. And another important command you probably interested is maybe the URL you were asking for. I will see if I can circulate this information after this meeting to speed up the process. I hope that's fine. Okay, so if we go back now, we saw the success message, like I mentioned, which means that the Windows virtual machine is up and running now. Now let's go and access that. Before accessing, like you know, we need to set up username and password for Windows. So I'm going to use a username, let's say cloud user, and I'm going to set a password. In fact, GCP will set a password for your Windows instance. So just copy the password and try connecting to the Windows instance. Like we already know, Windows uses remote desktop protocol. So if I click here, I should be able to access that instance with the password. You can leave the domain as it is, as empty, and press continue. Here you go. Now you have connected to the remote desktop of the Windows virtual machine we have just created. And this is my user directory on that Windows instance, Windows virtual machine. And I'm going to disconnect and delete this virtual machine because Windows virtual machines are expensive than the Linux virtual machines, as you know. And if I run this instance for longer, I will be charged for the resource usage. Okay, so I'm going to stop this Windows instance. Once it's stopped, I can delete that safely. You can perform all these operations via CLI, but in this demo, it's handier for me to use this web console. Okay, if we go back, then what's left? I will quickly also talk about probably cloud storage while we are deleting our instances. So in cloud, you can store structured and unstructured data. You can associate that storage with your virtual machine. The virtual machines are probably useless if you don't really store any data as in that. So while you are storing data into virtual machine, you have two options. I'm sure you are familiar with this. One is to keep a persistence volume, which means that the data you stored will survive VM crashes, restarts, or recreation. On the other hand, you also have an option to store the data within the VM, not really persisting outside, which means data die along with your virtual machine. So we'll see what are the various data storage technologies available in general in Google Cloud and specific to virtual machines. So in general, there are two types of data storage technologies in GCP. First is unstructured and second is structured. In unstructured data, there are two types. One is block storage and object storage. And in block storage, you have persistence just like we discussed previously. Local SSDs associated with virtual machines, and you also have random access disks. Within the persistent disk, then you have HDD and SSD, single storage disk, solid state disk, solid state disk. In object storage, then you have GCP, GCS bucket, which are the abstractions to store the data in GCP. That's so user is not directly interacting with the data itself, but through the objects in GCP, you can manage those GCS buckets. In structured data, then we have two types of structured data, OLTP and OLAP. In OLTP, meaning online transaction processing and online analytical processing. For transaction processing, we have Cloud SQL and Cloud Spanner in GCP, and for streaming and analytics, we have BigQuery and Bigtable. So in the case of virtual machines, you will be looking into this based on the type of data you store. Again, in the virtual machine, we already discussed the difference between persistent disk versus local SSDs. Persistent disks are attached with a network storage, but local SSDs are attached with an instance. Because of that, persistent disks will have redundancy built in, whereas local SSDs doesn't have redundancy. Persistent disks are bootable, local SSDs are not bootable. So yeah, some of the high level differences are mentioned here anyway. So now let's go back and see what's going on with our virtual machines. Okay, Windows virtual machine is stopped now, and I can safely delete now. I'm conscious about the time as well, so I have a couple of more topics, mostly, hands-on examples of various Google Compute Engine operations. But I don't know how's the feeling of the guys joined. Is there any questions, or do you have anything to discuss, or should we stop here and continue? I don't know if you can get me some feedback. I would prefer to make this more interactive. In that way, it's much more easier. Prajit, at least can you hear me okay? Or what do you think? Should we continue with more exercise, or we can probably summarize everything and stop based on the feeling of the guys in the room?
Yeah, Prajit is not in the room.
Okay.
He's not in the list of participants.
All right. Okay.
If you just touch participants down there, you can see who is in by name, not picture.
Okay. I see that. Yeah. Yeah. So should we continue for a few more minutes, or is it okay? If you're tired.
No, it's okay. If perhaps you need to rest some 5 minutes, 3, 4, 5 minutes here. Or...
Yeah.
We have been talking 1 hour and more, and 15 minutes. It's a lot. So you can, and after we can. It's good to go and drink some water myself.
Oh yeah. In that case, maybe we'll take a short 5 minutes break and then.
Yeah, just let it stay like that. And
perfect. So
you can write in the chat 5 minutes.
All right.
19, 21, 22 or something like that. If you write there, back,
okay.
Say back, so people. It's good. That to everyone.
Yeah. Okay. See you then in 5 minutes.
Yeah, good. Perfect. See you.
Yeah.
Oops.
All right, I'm back and I hope you can still see and hear me. Okay. Okay, so when we work with the Google Cloud Platform or any other cloud platform, one of the interesting feature or one of the interesting thing everybody looking for is how to access the logging, tracing, and other information. In Google Cloud Platform, there are inbuilt features which will allow you to access various logs. If you go back again here, you have logging, monitoring, debugging applications here. So we are going to see some of these for the virtual machines we have already created. For instance, if I go into the Cloudy Basket service, the logs can be visible from the Stackdriver logging. If I click here, that will take us to the operation logging, and all the logs associated with that virtual machine is stored within here. We can expand this and see more information about this logging at various log levels, either all logs or filtered based on the activity. Logging level, including critical, error, warning, info, etc. And you can also select the time. You can see first entry to start with if you like. You can download these logs for your own analysis. And this logging and tracing comes free for the compute engine resources you have created. But if you need additional logging, extra logging for your resources, then there will be an extra cost associated with that. But the default logs of any VM types comes by default with GCP. Let's go back now. Okay. There's a demo to create a persistent disk and associate with the virtual machine. I'm going to skip that because of time constraint. Rather than that, I will show a even more interesting example, probably how to configure startup script when you create virtual machine so that your virtual machine comes pre-configured rather than you create the virtual machine, then go configure that based on your requirement. So let's see how can we pre-configure a virtual machine during its creation. Let's go here again. Create instance. Cloudy Basket website, let's say pre-configured. Within here, I use all the default options. Allow full access to cloud APIs. I will allow HTTP traffic, allow HTTPS traffic, and in here, in the management options, you can see various options like management, security, disk, networking, solo tenancy, etc. Probably we will see some of these in a future session if there is any, but in this case, we'll just go for a small little feature you can make use of it. Under automation, you can see startup script. It's an optional feature, but very powerful if you use for your use case. So I'm going to use a small little startup script, which will basically configure the web server and create this virtual machine based on that configuration. So my small script is here. I will explain what's going on here in this script. So this is basically a small bash script which downloads or which performs the update on the virtual machine once it's created. Then it installed an nginx Lite web server on that virtual machine. And then it goes to the location in which the index.html is present, which is under var www.html. And it accesses this file and modify the content of that to something which is useful for us. So you can add as many information as you need, but within here, I probably will also add some custom information. So this is our startup script, and let's see how this is going to configure our virtual machine. I'm going to leave all other options as default. And off I create. So here is our Cloudy Basket website pre-configured. And if I access to this external IP from here, my browser has some issues sometimes in opening that. So I'm going to open that.
Control.
Oh, control, okay. Yeah, unfortunately, control doesn't work either. Could be something to do with my ad blocker. I don't know. Anyway, let me open in a different browser. And I'm going to access the website we created. Okay. Just give me a second. Yeah, there you go. So this is accessing the web server from the virtual machines we created, which is pre-configured. Even though this was a very trivial example, this is really a powerful feature. You can make use of this startup script to predefine and configure your virtual machine even before when it is being created. So this was a simple example of that. I basically modified the HTML code within the index.html page of nginx Lite web server. Yeah. So that was about pre-configuring your web server. And this is the script I used. If you want, I can paste this as well in the chat window. All right. Other than that, there are more advanced, hands-on labs working with the Google Cloud. Some of them which I usually do within here in Ireland and elsewhere is working with Cloud Compute Engine, which is an advanced topic than what we will discuss today, in which we go in deeper detail about Google Compute Engine. And another one then is cloud computing with container clusters, which is a Google Cloud Kubernetes engine with some of the topics like this, etc. So there are quite a number of such topics in cloud computing, programming, web development, etc. available. If you're interested, please talk with your GDG organizers. With that, I would like to thank you